The contaminant that we're studying is called nanosilver, and this is just very, very tiny particles of silver that are often weaved into the fabrics that make up garments, specifically or most commonly used in sportswear, so that the silver in the fabric actually kills any fungus or bacteria that cause bad odors. These little particles actually get washed out the minute that you wash your garments. And ultimately, this ends up in the environment. The main problem is that once it's, for example, in soils, it continues to act as an antimicrobial agent, and the concern is that the soil bacteria would actually be affected by that. My name is Veronica Morales, and I'm originally from Mexico. I studied environmental engineering, and I really love the outdoors. I love hiking and biking, and one of the things that I really love about science is, first of all, you get to come up with very creative ways to answer questions about nature that we don't understand. And secondly, I get to work on preserving the environment that I really like to hang out in. Currently, I'm a postdoc at the Institute for Environmental Engineering at ETH Zurich, and we are trying to understand how the silver particles move within soils. So we want to understand better how particles are filtered out in soils from water, and more importantly, what might cause soils to actually release these substances into water and basically contaminate aquifers. The primary difficulty of understanding processes that happen in soils is that it's really difficult to just look within the soil. And in order to do that, we created a transparent soil through which we could actually follow the behavior of these particles. For some of the first findings that we have from these experiments, we have noticed that salty soils are better filters for contaminants than non-salty soils. And we also tried to simulate what happens when there's a heavy rain event. And what we found out is that initially there's a spike of particles that are being released. And this sort of dwindles down to a very low rate if you wait a long amount of time. And essentially what this indicates is that soils can act as a steady source for contaminants if they're not properly managed. The final aim of my research is to be able to communicate to policymakers both chemical and other factors that put soils at high risk of releasing these contaminants in order so that the contamination can be contained and not spread all over the place. And a very exciting part of my work is basically being at the forefront of what is contaminant hydrology, and ideally to be able to have my work contribute to making society a little bit more sustainable.